All right, guys. So thanks for being here. I'm going to go ahead and get started. Just remember, I just want to kind of a few reminders. Don't forget that tomorrow or next week is the last week of this kind of limited virtual schedule that we're working on from the from 10 to about 3 o'clock or whatever. So after that, September 28th, we're going back to a full day from 8:40 in the morning to 4:30 in the afternoon, and not including if you guys have first or seventh period off. So if you haven't seen that schedule, don't worry. I will post it next week, and I will go over it, on Friday right before we get back to everything. I don't want to send it out right now, just because I don't want you guys to get confused. Schedule next week stays the same. I'll see you guys Monday, Wednesday, and Friday. Or wait, Monday, Wednesday, and Friday. Sorry, and we will continue going that way. I have this week so far, what we've kind of done, I've kind of just gradually brought you guys into the content and getting used to Schoology and whatnot. And I know that we've only done one assignment this week. It's going to stay that way even through today. Um, and Next week, I just want to warn you. Just I'm going to start bringing up the amount of content more next week, so that we can start moving a little bit quicker. Now that we're starting to get used to this, both you and I, because obviously it's a learning experience for me as well. So here's what we're going to do today, and you can see this on your screen. Go ahead and open up your 1.1 homework assignment. With the limited amount of time that we have today, I don't want to started a new thing. We will start that on Monday. If you haven't noticed yet, I changed the due date for assignment 1.1, homework 1.1, to Monday morning. Some of you have already finished it. That's great. But I want to go over some of the answers right now by taking from what you guys, whatever suggestions you have. If you have already turned it in, that's fine. You can pull it up. And if you want to make corrections, you'll need to unsubmit your assignment. If you can't figure out how to unsubmit it, let me know in the chat right now so that I can unsubmit it for you. And then starting in about 2 minutes, I'm going to start going over some of the answers by your requests, I should say. Okay, so go ahead and get your assignment open. I'm going to switch over to the view so you can see it on my screen. And let's see. Can I get a thumbs up from somebody if you guys can see that? I've got multiple things going on right now. Okay, thanks, Taylor. All right. So get that pulled up. If, like I said, if in the chat you are unable to figure out how to unsubmit for yourself, if you want to make corrections, let me know in the chat real quick, and I will unsubmit it for you. I've been playing with this all day with my other classes. So I think people told me in my earlier periods that there's a button that literally says unsubmit. So I think there's a couple different ways you can do it, but since I changed the due date, it should let you do that pretty easily. And I can send it back to you pretty easily too. So I'm going to just go ahead and dive right into it. On the front page, which is pretty much vocabulary, note heavy stuff, going through your notes, going back through what we had talked about. Was there any questions? Anybody have any questions about questions 1 through 4? Anything that you couldn't figure out 1 through 4? That should have been pretty straightforward, pretty easy. Don't be afraid of asking, or if you're afraid to ask it in front of everybody, send me a private chat. I won't tell you who. I won't say who it is. Let me know if you want me to answer one of those questions 1 through 4. Good, good. Okay, that's been pretty much the most part today. What about 5 and 6? I did get a couple questions from people last night, messaging me on the Remind, or sending me emails, or on Schoology message. By the way, let me just talk about that for a second. Guys, people were messaging me last night, like at 9:30 at night. That is okay. I have no problem whatsoever with you guys emailing me, messaging me on the Remind. I leave the Remind open for that particular reason. I get it. I was a senior with, as like you guys were, and I worked full time when I was a senior. And I get going to work and being working late. If you get home at 9:30 after work and you're working on your homework for the first time, because that's the first time you can get to it, and you have a question, feel free to message me. If I'm available, I'm going to answer that for you. If I'm not available, I might not get to it or see it till the next morning, unfortunately. But I will try to No worries, Angel. I will try to answer that as fast as I can. Somebody messaged me in the middle of the, like late afternoon yesterday, and I didn't get back to them for a couple hours. And unfortunately, it's because I was driving to San Antonio. We had a tennis match down there. Obviously, I'm not going to try to text while I am on the bus, driving the bus at least. So bear with me if it's a late response. But like I said, I don't mind that. Send me those messages. You're not going to bother. You're never going to bother me with those emails. If I don't get to it, then I just don't get to it. All right, until the next morning. But I'll always respond. Six, I got a couple questions on last night. There were some. The big question I got was, can you go through a vertex more than once? And the answer is yes. You can go through a vertex more than once if you're trying to find a Eulerian path or circuit. You just can't use an edge more than once. Now, next week we're going to do some graphs where you can't do that, but we haven't gotten there yet. So the answer to number 6 is yes. If a graph has a circuit, it definitely has a path. Both of them use every edge exactly one time. The only difference is the circuit starts and ends at the same spot. A path will end at a different spot than it started. Okay. Any questions on number 7 or 8? Any questions on number 7 or 8? Don't be afraid to ask if you couldn't figure it out. Either unmute yourself or send it in the chat. So it looks like we're good. I can't see everybody, so you'll have to actually get my attention some other way. But I think we're good. I've gone through a lot of your assignments, ones that were submitted at least. A lot of you coming up with some good real world scenarios. Mail delivering is a big one, trying to find the best delivery routes. Another big one I saw was snow plowing. If you're snow plowing streets, if you're a snow plower, you're not going to actually use every single road because you're only going to go down the road one time because you're going to snowplow it once. Help on number 7. Okay. So what's the best way to determine whether or not a graph has a Eulerian circuit? So let me do it by using this as an example, and I'm gonna annotate on top of here. Now, here this graph has a circuit because we started and ended at B, and we used every edge once, so that we know for sure that it has a circuit. You can see the solution right there. The quick and easy way to determine whether or not a graph has a Eulerian circuit is looking at the degrees of each vertex. Now, remember the degree is I'm going to use a different color actually. Clear that. Remember the degree of a vertex is how many edges touch each vertex. A has a degree of 1, 2 because 2 edges touch it. B has a degree of 1, 2, 3, 4 because 4 edges touch it. C has a degree of 1, 2. D has a degree of 1, 2, 3, 4. And E has a degree of 2. Every single one of those vertices has an even degree. So the answer to that question is, if all the vertices have an even degree, then yes, it has to have a Eulerian circuit. Okay, so every single vertex has to be even though. Every vertex has to be even. Now, if even one of them is odd, it cannot have a circuit. It might have a path, but it definitely will not have a circuit. Angel, does that answer your question? Good. All right, anything else from the front page? All right. So here's what I want to do on the back. I told you guys, I think I didn't tell you, and that's why I sent the remind last night. There is, on the back of 6, there's only one of them that's neither a path nor a circuit, the one that has no solution. Okay, I'm going to go over that, Dominic. In the chat, if you figured out which one is the one that has no solution, go ahead and put that number in the chat for everybody to see. Go ahead and put that in there. Which is the one that had no solution? It's just not possible. Yeah, Maddie's right. Number 10 is the one that has no solution. That means that all the other ones do have solutions. So if you put neither for more than one, go ahead. Let's fix that right now. You can go ahead. If you didn't put this in there already, 10 has no solution. It was pretty quick to figure that one out, that there is just no way to do it. So go ahead and write in neither or no solution for number 10. And what I want to do is I'm going to take, can you go over the loops? I found one for 10. Savannah, can you let me do this. Can you tell me, can you unmute yourself and tell me which way you try to do for 10? Okay, what did you start? Okay. 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 Okay, but then you forgot this one right here. You see that? Yeah, yeah. Yeah, good one. Yeah, it's kind of every now and then you miss like just seeing one, but yeah, that one does not have a solution. Okay, so here's what I want to do for the first two people that put in a number in the chat. If you could not figure one out, put the number in there, and I will do the first two that come up in the chat. If you couldn't figure one out, I will do two of them right now for everybody to see. So 13 is one I've been getting all day. And any other one after 13? Okay, well, let me just start with 13 if somebody else. Angel, I can't do all of them. All right. I'll do 9 and 13. So I'll start with 13. All right. I'm glad you picked 13 because here's one thing I want to point out. Look at number 13, and as you're glancing over the vertices, I'm looking at I see C really quickly, and I notice that C has a degree of 1, 2, and 3. That means that it doesn't matter what the degree of any other vertex is. This graph cannot have a circuit. There's no possible way. So I just need to only notice that one only has an odd degree. It cannot have a circuit. Now there is a path, and there are several answers for this. Does anybody have a solution that I want to share out, and I'll just trace it for everybody else to see? Anybody? I mean, I have a solution that I can give you the one that I have, but there is several answers to this problem. Who is that, Maddie? Jayla, I can. It would be very difficult to do that because there's probably dozens and dozens of different answers. Because for every path, you could just like reverse that too, and so you would find a reverse one, and then you could probably start at any one of the vertices as well. So, how many there are? There's a lot. There's a lot. Yeah. So I'm going to show an answer right now. I'm going to put up Maddie's, and yours might be similar to hers or it might be different. But there are a lot of different answers. So Maddie, tell me where you started at. Okay. So I'm going to put a little ST right here. This is the starting one. And then I'll use a different color to show. All right, go ahead. Okay, so first step, and I'll just label that 1 so that you guys can follow along. It's easier to do it that way too, so you don't lose where you were at. Go ahead. Okay. Obviously here. Okay. Okay, so completed the square first. And then, okay. Okay. That's number 8. obviously here. So I'm going to put in and at E. Now, obviously, guys, I've done this. This is my fourth class today, and I've had 4 different answers for this. And there's a lot of different answers. So, Jayla, as much as I would like to tell you how many different answers there are, there's just so many different solutions that it would take a very long time to come up with every single possible solution. But I'm sure if you figured one out, I'm sure yours is probably correct too. And I can take a look at it too when I look at you guys' homework. So if you guys didn't get an answer or couldn't figure out, why don't you take a screenshot or take a picture of this real quick, and you can put it on your own assignment, because this is one of the many solutions. If you got a different one like Jayla did, then don't change it. You've got a correct answer as well. There's plenty of correct answers out there. Cool. All right. I'm going to leave this up for about 10 more seconds. If you need me to keep it up for longer, you need to put it in the chat in the next 10 seconds. Take a picture of it with your phone or a screenshot so that if you need to try to copy it later. 5, 4, 3, 2, 1. All right. All right. So the next one people asked about was number 9. And here's what I'll do. Here's what I'll say about number 9. Again, this is the way you should be starting it out each time. If I'm looking at the degrees of every vertex, A, B, E, and F all have a degree of 2. They intersect 2 edges. C and D both have a degree of 1, 2, 3, and 4. 1, 2, 3, and 4. So before even looking for a solution, we already know this graph has to have a Eulerian circuit. So go ahead and put circuit in for that one. You know that it exists. Now we can find a solution, and there are, again, dozens of them that exist, dozens and dozens of different possible solutions. Don't forget, for the question that we just did, number 13, put in path. Make sure you put in a path for that one. Okay, so I'm going to clear this out, and then we'll find a solution. Does anybody new want to walk me through a solution they came up with? Anybody different? Okay, well, I can give the solution that I have. I started at C, so I started here. And then I went to A, so there was my first move. And then I went to B, my second move. Went to D, that was 3. Went down to F, it was 4. Over to E is 5. Up to C is 6. I went across to D, and either way, you could have gone down the loop one first. There's 7, and then I went back to C. There's my 8th move, and then I obviously ended here as well. So there's one solution. I forgot, somebody a few minutes ago asked, how do you do the sequences? The sequences is optional if you're not drawing like this. If you draw like this with the numbers, no need to write the sequence. But for some people, it was easier for them to not draw on there, or they might have been doing it on their phone, or whatever the case may be. And you could just write the sequence out by putting the first letter of the vertex that you start with. In my case, it would have been C. And then I went to A. And then I went to B. And then I went to D. And so on. That's how you would write the sequence, and you would just write the order of the vertices as you were traveling to them. So again, that's optional. That's only if you didn't draw them on your paper, or on your screen. And if you do both, that's even better, because I'm sure you'll probably learn it a lot better that way too. Okay. A lot of the times, especially when we get to a quiz or a test, if it's a multiple choice question, I'll have it as a sequence, because that's the easiest way to write that. On a multiple choice question for something like this. So it's good that you're practicing both, Dominic. Anybody need me to leave this up for any bit longer? That's correct. 10 has nothing. 10 has you don't put anything down at all because there's no solution. Okay. So I think hopefully you guys have enough information to finish this if you didn't already. If you unsubmitted it, make sure to resubmit it after you're done and make your corrections. Like I said, not going to do anything new today. We will kind of increase the content level next week. Let me stop sharing here for a second. If you guys need any individual help or you're unable to access your file or something's messing up, you can stay on. Otherwise, I hope you guys have a great weekend, and I will see you guys on Monday.